Hello, can you hear me, Dhruv?
Yes, sir, but your voice is a little low.
Huh?
Your voice is a little low.
Sorry, I cannot hear you properly. What are you saying?
Your voice is a little low.
Your, what were you saying, Dhruv? Can you write it down? So can we start? Should we start the class? Okay, my voice is not clear. Now is it fine?
Yeah, it's good.
Okay. Okay. So uh, we were studying Ohm's law now.
Yes,
We were studying Ohm's law. So Ohm's law is very important. Okay. So we said that Ohm's law is V is equal to IR. This is Ohm's law. Where V is the potential difference. As I explained, what is potential difference? I is current and R is the resistance. Okay. And we can even draw the plot of V is equal to IR. The plot will be like this. This is V, I, and this will be plot V is equal to I. As you can see, this plot will go through this center of this, okay, because it is in the form of y is equal to mx. Y is equal to mx. So we see in equation y is equal to mx, this m is the mass. Sorry, this m is the slope. In this equation, this m is the slope. So here, slope of the curve. Here the r is the slope of the curve. What is slope? If this is angle theta, then tan theta is defined as slope. Tan theta is described as slope. If we say that this theta is increasing, it means the slope is increasing. Okay. If theta will increase, then tan theta will increase. You can see the values of tan theta, it increases with the value of theta, and then slope will also increase. So what is this slope? This is the slope, tan theta. It means this is the lower slope. Now it has higher slope. Okay. This has higher slope because theta is large in this case. So in the same way, if we say that if the resistance will increase in the wire, so what we are having is this. This is the wire. Okay. We are putting a battery here, which provides the potential difference V, and a current is flowing due to that. Current I is flowing through this wire. As I told you, the mechanism, there will be some resistance to this current in the wire. So if I say the radial, this resistance is increasing then what will happen? This slope will increase. This will increase. This will be like this. If R is very high, then this curve will be like this. P is equal to R. Okay. So this is called the Ohm's law. It is very important. Even in the higher classes, you will be using this. This is called Ohm's law. It was given by a physicist named George Simon Ohm. So this is, so do you have any doubt in this Ohm's law?
No.
So now there are 2 to 3 things which you can notice in real life if you will find. Then what are these things? If you will increase the length of the wire, so this was the wire. If you increase its length, then there will be more resistance. If its length is large, then the resistance will also increase. You'll also see that if the wire is more, has this thickness is very high for the wire, or you can say the cross sectional area. What is the cross sectional area? If we cut this wire, then you will see a cross section like this spherical cell. That is the cross sectional area. So you will also see that if you will increase the area, then resistance will be lower for that wire. If area increases, then the resistance decreases. If length increases, then resistance also increases. So you need to know these 2 things. And this resistance, okay, so as I told you, this resistance does depend on this length and area. If length will increase, then resistance will also increase. So if we can say that if we use wire with higher cross sectional area, it means thick wires, then we can decrease the resistance and the flowing of current will be easier in them. Current will flow more easily if we can increase the thickness of the wire. And it also does depend on the material of the wire. Okay, as I told you already, that this resistance does depend on the material also. Material used in order to make the material of the wire. For example, we can say that for silver or for copper, okay, for copper you can say, for copper there will be low resistance, okay, resistance will be very low for the copper. That is why we used copper wire. So in these electricity wires, you will see that there is copper inside. Okay, it is made up of copper. And you see some wire, electricity wire, then normally there is PVC on that, which is the plastic material that you see. PVC So this PVC is insulator, okay? So it can save you from the electrocuting. So you do not get current. So that is why this PVC is used, polyvinyl chloride. So this PVC is used, but if you will peel this PVC off, then you will see copper in it. There is just copper. So a wire is made up of copper. These electricity wires are made up of copper. So the resistance is very low for them. So current can flow easily. Okay. So now we will see, and there is another other example also, silver. For silver also you will see this resistance is very low. Resistance is very low for silver. So silver is also a good conductor, electricity conductor. So it is a good conductor. The copper is also a good conductor because its resistance is also very low. But the silver, the resistance of the silver is very low, but we do not use silver as wires because it is very costly. Okay, it is very costly, and there is a little difference between the resistance of silver and copper is less costly, so we use copper instead. That is why we use copper. Cu. Cu is the symbol for copper. Okay, copper wires. Okay, so that is about the resistance. Now, as we told you that this V potential difference has some unit, and the unit is volt. As we say that in household electricity, we say that there is 240 volt, or even when we discuss about the mobile phone charger, then we say that my phone charger is of 5 volt or 10 volt. So that is the potential difference unit. Okay, that is the potential difference. And current is measured in ampere. It is written as A. Current is measured in ampere. So we say that 5 ampere current, 6 ampere current, 7 ampere. So you can see these symbols on your charger of mobile phone. You will see for different chargers, you will find the voltage and ampere current for that. And how do we measure these? There are equipments in order to measure the current and voltage. In order to measure the voltage, the equipment is called the voltmeter. And when we want to measure the current, then the equipment is called ammeter. The equipment which measures the current is called ammeter, and the equipment which measures the voltage is called as voltmeter. So that was the basic things. Now you might be surprised that what is the unit for R, resistance. What is the unit for resistance? Then you have two ways, because you know the formula V is equal to IR. So you know the formula of R will be V divided by I. So you can write the units of these two quantities and you will get the unit of R. So it is volt per ampere. Volt per ampere. But in SI unit, this resistance unit is also ohm. Okay, it is represented by this omega sign. The unit of R is ohm. This is represented by omega sign. It is equal to volt per ampere. Okay, this is about the resistance. Now we will discuss the combination of resistance. Okay, the combination of these resistors, because we can use different wires which has different uh, resistance. As I told you that different materials have different resistance, so we can have multiple different wires which has the different resistance. For example, see, some wire can have the resistance R1, some wire can have the resistance R2, some can have R3. And how are they represented? They are represented like this. The resistance are represented by these signs. But when you will see resistance in real life, then they will not be like this. There will be some, like, cylindrical shape and some different colors on it. You can even see in your book there is a diagram of the real resistance. Okay, so now we will see the combination of resistance, or the combination of resistors. It means we will see that if some resistor is R1, okay, and some other resistance is R2, then what will be the total resistance of this wire? If some wire has resistance A and some other wire has resistance B, then we want to find out the total resistance, the net resistance between A and B. So we can see that these resistors are in a combination which is called the series combination. Okay, so we will find out what will be the R equivalent. It means the net resistance between A and B. Okay, so now there are two kind of combinations. There are two kind of combination of resistance. The first is series combination, and the next is parallel. First is the series combination, second is the parallel combination. So if we add a resistor like so you can see that if you say that this is the end point of the resistor, okay, and you can say it's a starting point. You can just say that it is starting and this is it. So if you add another resistance in a way that its end point, if you add another resistance in a way that its starting point or its end point, this end point, match with this starting point of the first resistance. This is R1, this is R1. So if we connect this end point of this resistance R2 with the starting point of this resistance R1, then it is called the series combination. It's called series combination. If you match this is the end point, this is the starting point. So what have you done? The end point of the resistance R2 you have connected with the starting point of the resistance R1. This is called the series combination. there can be any resistances, resistors in series like 1, 2, 3. This is the series combination. Okay, so now we want to find out the R equivalent. What is the R net between this point and this point? You can say this is A point and this is B point, and you want to find out R equivalent. Okay, so what we do, we add this by a circuit. Okay, we add these resistances in circuit, or we can, in order to make it simple, we can even consider. Okay, so we are starting from here. Okay. So we will do the series combination now. So just imagine if there are two resistors and we add these two resistors by a battery. Okay. Battery and current also. You can also connect it with the emitter. And I told you that what is emitter. I told you what is an emitter. Emitter is used in order to measure the current. Okay, emitters are used in order to measure the current. This is plus sign, this is minus sign. Now, as you can say, this is R1 resistor, this is R2 resistor. If we apply this potential difference, then the current will start flowing. Let's say it is current I. Now, always remember two things in this circuit. Okay. The current will be same at this point, at this point. The current will not be divided if the resistors are in the series combination. Okay, the current will remain same if these resistors are in series combination, and the potential difference will be different for each resistors because V is equal to I R. So we can see from this relation if R is different for different wires. Like for this wire R is R1, so it will be V is equal to I R1, and for this wire it is V is equal to I R2. So both are different, so that is why this potential will also be different at a different different resistors. So you can say it is V, it is V1, it is V2. Because the resistance is different for each wire, then it means this potential difference is also different because this is these are related by this V is equal to IR. Now, if we want to measure the potential difference at this point and at this point, then what we do is we add a voltmeter. As I told you, that a voltmeter is used in order to calculate the, in order to measure the voltage of the wire or of the equipment. Now we add another voltmeter here as well, so we can measure the potential difference between this point and this point and this point and this point, and they will be different from this relation. Okay. So we can say that V1 is equal to IR1 and V2 is equal to IR2. But we also know that this potential difference is V between this point and this point. Between this point and this point, the potential difference is capital V. So if I say that when current was flowing through this wire, then due to this resistor, there was some potential drop, or we can say voltage V1 here and V2 here. So what will be the total potential? What will be the total potential or potential difference? The net potential difference will be V is equal to V1 plus V2. Because you can imagine potential difference as some energy. Okay, just imagine it is not energy, but if you imagine the potential difference as energy, then you can say some of this is the total energy, some of the energy got wasted here at the resistant R1, which is V1, and some of the energy got wasted here, which is V2. And then what is the total energy? This is the total energy, which is V1 plus V2. It means the V is equal to. So you can imagine that way, but they are not equal. Okay, the potential difference and energy are not equal. They are different quantities. Okay, so now if we use this relation, V is equal to V1 plus V2, then we can say that V is equal to V1 means IR. V1 is equal to IR plus V2 is equal to IR. So now we can take I as a common quantity and R1 plus R2. So this is the net potential. So now we know this is the total potential difference. This is the total potential difference between this point and this point. You can say this is point A and this is point B. So this is the total potential difference between this point and this point. And what is the total current between this point and that point? Small I, because current will not change if the resistors are in the series combination. So from this equation, you can write V by R is equal to R1 plus V by I is equal to R1 plus R2. V by, and what is V by I? We know V is equal to I R. This is the relation. We know this relation. This is called Ohm's law. So what will be V by I? R. So this is the R, total resistance. This is the series combination of resistors. This is the series combination of resistors. Now we will see the parallel combination of resistors. Parallel combination. So the parallel combination is in this way. Parallel this is the parallel combination of R1 and R2.
Yes.
So in this, what we do, if we are saying that if we say that it is the end point and it is the starting point. So now if we add end point of one resistor to the other end point of the other resistor, what we are doing, we are adding this is also the end point of this resistor and starting point of this. So how are we connecting? Now this time we are connecting end point of the R1 with end point of R2. This way. You can connect in any way. You can like this. So now this end point is connected by this end point. So if we connect one resistor's end point to the other resistor's end point and one resistor's starting point to the other resistance starting point, then it is called the parallel combination. Okay. So that's why it is called parallel combination. And what we did in series combination, we have added end point of R2 with the starting point of the R1. You can see this connection. We have connected end point of R2 with the starting point of R1. But here we are connecting end point of R1 with the end point of R2, starting point with the starting. So this is called the parallel combination. Yeah, you can. Now always remember in this case that current will be divided in parallel combination and the potential difference will remain same. It is just the opposite of the previous case. It is just the opposite of the previous case. Now what I am saying is that when like current was going like this, if current was going like this, then some of the current will go here, say I1, and some of the current will go this side, say I2. Okay. So we are saying that the current is divided in the parallel combination. But in the series combination, if I current was going here, then here also it was I current, and here also it was I current. But in the parallel combination, the current is divided. Then you can say I is equal to I1 plus I2. Of course, because whatever the current was coming from here, it got divided into I1 and I2 part. And again here it will be I current because it will be added I2, I1. This time the potential difference will remain same from this point to this point. So in the parallel combination, the potential difference is same. So for example, if you add a voltmeter here and a voltmeter here, you will get the same potential difference. Okay. So here also we will have potential difference V. Here also we will have potential difference V. So in the previous case, we has written the formula of V. This time we will write the formula of current. Because in the previous case, we said that V is equal to V1 plus V2, but now this time the potential is same, but this time we will do the opposite thing. We will write I is equal to I1 plus I2. I is equal to I1 plus I2. I is the total current. Now we know the relation between V and I. V is equal to IR1. IR, okay, V is equal to IR. So what is I equal to? V by R. So for this I will be the I. This I1 will be V divided by R1 plus this will be because both of the resistance has the same potential difference. Why? Because the this potential difference is not divided by the parallel combination. In the parallel combination, it will have same potential difference. Now this I also can be written as V by R, total V by total R. It is total R equivalent, or you can even say R. So what I mean by R is R net or R equivalent. So now in this equation, you can cut these potentials, okay, and you will have 1 by R equal to 1 by R1 plus 1 by R2. This is the parallel combination. Okay, it means if the resistors are added parallelly, then that is how we will calculate the total resistance. If the resistors are added like this parallelly, so if you want to calculate the total resistance of this between this point and this point, then we will calculate it in this way. And what is the benefit of calculating the total resistance? Now, as you can see, this is a little bit meshy network, or you can see a meshy diagram. Now you can just remove it by putting the R equivalent. So calculate the equivalent of R1 and R2, and then just draw one resistor with the R equivalent. They are both the same thing. Okay, this is the benefit of calculating the combination, the net resistor. So now it is not only true for two resistors, but it is true for any number of resistors. For example, in the series combination, if you have uh, multiple resistors, so let's say it is R1, it is R2, it is R3, it is R4. And if you want to find out the equivalent resistance, okay, of this wire, so then you can replace this wire just by a single resistor having the equivalent resistance. And what is this equivalent resistance equal to? In the series combination, we add R1 plus R2 plus R3 plus R4. So this is how we add the resistors in series combination. So it is true for any number of the resistors. It is also true for the parallel combinations also. So if there is three resistors, then it will be that this can be removed as this one's equivalent resistance, which is What is this equivalent for the parallel? 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, so this is the combination of the systems. It is very important. Okay, it is very important. These combinations. So now we will see a little bit of heating effect of wire. I think the time is over, so we can start this next topic, heating of a wire, in the next class. Okay. So in the next class, I think the chapter will be completed. Okay. Okay, thank you. So the class is completed by now.
Thank you, sir.
Huh?
Thank you.
Okay, welcome. We will continue from this point.